Hello. Um, Hi everyone. Uh, this is Nilabhra from IIT Kharagpur team. I hope my audio is audible and I am visible to you.
Sydney, you're on mute, but I can't hear the presenter.
Hello. Good afternoon everyone. Am I audible?
Yes.
Hello.
We still have
Yeah.
a few more minutes to go. I'll call you guys on in another 4 minutes when we'll do a quick AV check.
Okay.
Yeah, see you shortly. Right, looks like we're at time. So I'll invite the first team for today, Indian Institute of Technology. If you all want to switch on your video and then also share your slides, we'll make sure that you're able to advance them. And then if everyone can just unmute themselves and state their name so we can make sure all the speakers have their audio in place.
Mm, Good afternoon everyone. Uh,
Yes,
we are from IIT Kharagpur and is our screen visible? Just
not
checking.
yet.
Mm,
Yes, we see it now.
okay. So so can we start?
So we still have another minute to go. I'll let
Okay.
you know when you can
Yeah.
begin. And are there
Fine.
any other speakers that want to check out their audio quality?
Presently, it's fine for us. One. It's okay then. See, like presently, I am the only one speaker. Will
Got
be
it. All
presenting
right.
and telling. So,
Sounds good. We have
yeah.
another minute to
Thank you.
go.
Yeah.
All right, you may begin your presentation.
Yeah. So, um, good afternoon, everyone. Warm regards and thanks from Team Sakti IIT Kharagpur to provide us this platform to present our design. So, to start on with our design, it's been now named as an Project 4S. Here the 4S, before going into the main design body, I would like you to introduce with one S is being the Surya, the sun, the major principle or the strategic center of our design thoughts. Another being the Sahisnu or the empathetic design we are doing for the clients and also keeping the mind for the nature. One other being the Sabuj or the green, the biophilia, the biophilic salutogenic effects we are creating along with our design senses. And binding all together is the sthiti or the greater goal of all these net zero ideations being the sustainability. So to start on with our team ideations, we are in 14-member multidisciplinary stream of the students from IIT Kharagpur. We are guided by two of our respected professors and been associated with five project partners as well as industry partners who has helped us in times when we need. To highlight our project brief, we are designing an office campus in India, New Delhi, Noida region that comes in the ASRE 1A climatic divisions. As you can see, a small tree plan presented here, the annotated white building among the whole major campus coming up in that Noida region is our major concern, and it's following the guidelines of our competitions, being a total build up area of near about 21,364. The major demand from our client side was not only a net zero energy building, but along with that to have a net zero energy, net zero carbon, as well as net zero water building to present. And also keeping the theories of the active, the passive strategies, and a design for the future or a futuristic design passion they wanted to see. Just highlight for our design brief, our UI limit from till where we have reached in our design processes are being presently 96 kilowatt hour per square meter per annum without renewable energy systems. And if we incorporate the present renewable energy systems in our site, it's been totally acting as an presently net positive building of -8. And how we are planning those, just presenting in next one slides. Just if we, to give you a brief idea of our office buildings, the sector where it is coming about is the main hotspot in India to have those buildings all together. And the office buildings presently counter 15% of the global energy demand. So our building creation in this sector will create a precedence effect that can followed on the next on the building field coming there. So it is an important for us and the other stakeholders also. To conceptualize our design ideation along with net zeros, as we mentioned in our introduction also, the sun, the nature, the overall circularity along our designs, the green-gray balance, right, the how the waters and the microclimate. As we are designing in the 1B sector, the climatic conditions demands other than our gray build form the other design micro neighborhood to support it so that we can implement the passive ideations much more effectively. So that's our already regarded there, and this is we are presenting just a overall conceptual ideation of our all tools. Also, just to mention, our net zero building before starting on in the operational level, we tried to touch on little upon the embodied energy and the embodied carbon level considerations along with that, because where we are presently designing that Delhi region or the Indian economically developing sector, along with the client aspirations, the UI limit crosses 200 to 300. And there, if we can propose a limit in between our 90 to 50 range, that will be really helpful for the coming days. And also another factor in our design overall ideations will be considering the performance gap reduction through our design processes. Just to highlight our design aspects, the major part of the building shared are greater than 60% area for the open office and the co-work spaces. Our design process follows from the macro campus understanding their functional zoning to micro that build form. We have segmented the building parts in three greater categories. One build the building enveloping tectonics, one building the building operations, and another building the building structural formations. Just in one example for if one can take a building envelope, overall building enveloping macro format to fenestration details, like these stages, we have tried to implement some design strategies, try to validate those, and will present through our next major start. So major first focus is our the architecture from our building architectural layout. You can see just in the plan as noted, the green, blue, and the microclimatic intrusion of the small areas in between the layouts, the elongated floor plates that will eventually help in utilizing the natural ventilation and the lighting processes as we'll proceed forward. So architecture is complementing to our engineering demands as we are proceed by like of overall whole structural core, operational, and the fenestration outlooks. Just to highlight, our fenestrational details has also provided resilience to the whole build mass because the heat waves are predominant in these areas. To focus on the building operations along with the functional, some passive in these blue areas, natural and overall active spaces, the building operations positions in the particular scores and optimizing those nodes are taken together. With building core being rigid, the affordable, removable facade patterns, rechangeable, those things has added to the values of the project, which can suit out the initial cost for some time, but later on the post creation stage that can help us much more value creations. Moving forward with the materiality and the innovations, the terracotta locally available parallel to glasses are being taken together in the node. In the building operations, with the natural ventilations creating the stack effect along the building macro format, the intelligent displacement ventilation in active processes and the overall indoor experiences keeping for the all occupants are being the major focus also there. And in their hybrid process of the intaking AHU ground heat release processes, those are being taken though. In the daylighting from macro neighborhood setting study to Chaja setting along the sun angles are being noted. And overall, these are conceptions. In the PV parts, with the major full PV of the normal sectors, we have tried to integrate OPVs in the neighborhood, those canopy creations that can add to the shading as well as that can utilize the solar insolation and dew source. To conceptualize fully our design into one part, as you can see for the base UI of the building
All
207
right,
with basic
Nilabsha,
passive,
I'd like
yeah,
to interrupt you just for a little bit. We're at time, so if you want to just summarize in a sentence and two, that'll be great.
yeah,
Thank you.
yeah. So just summarizing in a sentence, just you can see we're just end of the presentation. The base was 207 there, and now we are reaching 159 with basic strategies without implementing our intelligent zoning. And with basic strategies, we are attaining 159, and now the PV present there are making the building fully energy positive. So next on, we are planning to move our design processes, integrating multi-objective particle swarm optimizations or multi-objective oriented optimization. Now we presented our ideas in segmented manner. We'll try to next on our design stages, collaborate those and create a much more optimized solution. Thank you all.
Thanks, Nilabsha. That was a great presentation. I'd like to open it up for questions. Lisa, would you like to go first?
Did you say Lisa or Amy?
Oh, either of you. Amy, if you have a question ready, we can go ahead.
I'm good, thank you. I don't have any questions.
Got it. Lisa, do you have any
Thank you.
questions that you'd like to ask the team?
It was a lot. It was great diagrams, great overall concept. I'm not sure if I'm supposed to be giving comments back right now, but there's a lot there, and I was really impressed with a lot that I saw. I don't have any specific questions. I'm still sort of taking it in, and I did just pull up sort of your summary data sheet as well, just to sort of look back at some of those numbers and data that you guys presented on. Were you able to get to some of your zero energy goals for energy and water?
Excuse me, Lisa. Can you just repeat like your last sentences came?
Yeah, I was. Were you able to, in your modeling so far, have you been able to reach your zero energy goals, or are you still working on some of the details to get there?
Lisa, like operational level, I think that we are being at par as I showed you the simulation model. Like till now, the basic operational level, with adding the shadings and the other things, we have reached 159. But our goal is to reach 90, and we had not till done that intelligent zoning as we presented. So I think that next on we'll reach that net zero in a much more better format. But for now, for the basic PV operation efficiency in 50%, we have reached.
Great, thank you.
With considering the basic baselines. Thank you.
Thanks for the question. So I'd like to thank IIT once again for presenting. You guys did a great job. So we do have a break right now between 12:20 until 12:40. So we'll see you back for the next presentation by Illinois Institute of Technology. Thanks, everyone. All right, we're at time. I'd like to invite Illinois Institute of Technology for their 2-minute AV check. If all the speakers can turn on their video and then share your screen so that we can make sure we can see your slides.
All right, hello, we're from Illinois Institute of Technology. Can you see our screen and hear us okay?
Yes, we see your screen and you sound just fine.
All right.
Awesome. So we'll wait until 12:42 p.m. for you to begin. I'll let you know when you can get started. Thanks so much. Right, we're at time. You may start your presentation now.
Hi, my name is Haley Robbins, and I'm here with Alyssa Thompson to represent the Aspire office building team. We are a group of 10 architecture and architectural engineering students from the Illinois Institute of Technology in Chicago, led by Professor Eduardo Carati. Before we begin, we'd like to take a moment to thank our industry partners, as well as our faculty consultants who provided us with their valuable support throughout this project. The Aspire office building is located at the mouth of the Chicago River on the site of the defunct Chicago Spire, which failed in 2008. It left behind a 110-foot diameter and 76-foot deep hole in the ground. Across Lakeshore Drive, an infill slip called Disabled Park, historically tied to our site, has remained undeveloped for over 2 decades. Our project aims to revitalize the existing site and the adjacent park and create a new precedent for the office of the future. After the pandemic, studies found that most people prefer a hybrid model for work, encouraging a stronger work-life balance. Aspire is located in the near North Side neighborhood, shown here in yellow. The neighborhood is primarily a working neighborhood with high levels of education and a strong presence in the business district of the city. The site, 400 Lakeshore Drive, is in a prominent location along the city's Riverwalk and close to the Loop, the heart of downtown Chicago. It is surrounded by well-known landmarks of the city, such as Lake Point Tower, the St. Regis Tower, and Navy Pier, as well as many other residential buildings. Aspire embraces the Foundation Hall and DuSable Park, enhancing the park space surrounding it. This entices visitors to come through our site, revitalizing the foot traffic in the area. The circular paths bring attention to a reflecting pond in the Foundation Hall and provide peaceful, scenic meandering paths around our building. The massing of the building is evolved from the typical office box, which is then raised on a 2-story podium similar to its neighboring buildings. The 3rd and 9th floors are pulled in to create intermediate balconies. The form is then designed for solar optimization, angling the facade and roof at 35 degrees to capture as much solar energy as possible. Here's a closer look at the angled facade and roof, displaying our array of solar panels. The building is 14 stories tall, with 8 office floors, 3 floors of amenities for the occupants of the offices, and 2 floors of public amenities at the base of the building. The angled roof houses the mechanical spaces. The ground floor and 2nd floor engage the occupants and visitors to the building by providing food services like a cafe, food stalls, and a restaurant, and a daycare for working parents. The office amenities include a gym, outdoor terraces for the occupants' wellness, and conference and lounge spaces for people to gather. The typical office floor has 4 major programmatic zones. The workspaces are laid out in an open floor plan, while private meeting rooms on the east and west provide spaces for collaborative work. The break room, including a small kitchenette and lockers, and the wellness room both promote mental well-being and a stronger work-life balance for the building occupants. Here's a rendering of what an office floor might look like, full of natural light and warm wood tones, and offering beautiful views of the city's skyline, the Chicago River, and Lake Michigan. From the engineering side, we have a water source VRF system with a dedicated outdoor air system. Our plan is to collect rainwater from the roof and store it in a 190,000-gallon tank in the hole. The water will then be sent to a cooling tower and be used to feed the water source VRF system. For the air side, we have an air handling unit to bring the outdoor air into the building. Here you can see the general layout of our airside and VRF piping systems, with the main mechanical equipment on the 14th floor penthouse and the cooling tower and pump on the main level. Applying solar panels on various facades is our main strategy to generate electricity. After several analyses using the SAM tool from NREL, monocrystalline silicon solar panels were chosen for this design as they had the highest energy generation. Bifacial panels are used on the south facade to generate even more energy, leading to about 2.7 million kilobTUs per year and a target EUI of 11.8 kilobTUs per square foot. 2 different energy modeling softwares were used in the design of this project. Sapphira is less detailed and was used to optimize the massing,
while Open Studio was used to go into more detail about the building materials, HVAC systems, spaces, and thermal zones. We will be continuing to optimize the Open Studio model going forward to reduce the EUI and find a balance between the two softwares. As seen from the monthly energy consumption, Chicago is a heating-driven climate, and the project was designed with this in mind. Here we can see the energy consumption compared with the PV generation. We need to increase our PV generation and reduce our building energy consumption to find a balance between them.
To take a holistic approach to design, our building harvests rainwater and uses native plantings to reduce pollutants and water runoff. With a roof area of 18,300 square feet, the building can collect about 445,000 gallons of water annually. The cistern for this volume of water is being stored in the hole from the Chicago Spire under the reflecting pond and with an overflow outlet into the ground. The landscaping on the site uses plants such as goldenrod, blue flag iris, and bergamot that filter stormwater and road runoff before reaching the Chicago River, preventing pollutants from entering the water. The bifacial solar panels, our solar chevrons, are tilted 35 degrees for optimal solar gain. They are also used as solar shading devices, providing shade in the summer and reflection of light into the spaces in the winter. The construction uses thick layers of insulation under the solar panels and on the east and west facades, as well as triple pane glazing, in order to prevent energy loss. Terracotta facade panels and mass timber structure is used for a lower carbon footprint.
The cores are located in the middle of our building to maximize the access to natural daylighting in the main program areas. The angled facade and solar panels also act as shades to reduce glare. The building automation system is connected to the heating and lighting systems to improve comfort. Reserved spaces can be set at desired temperatures ahead of time to reduce wait times from adjusting thermostats, while circadian rhythm lighting will change color temperature and intensity based on the time of day to mimic the natural circadian cycle. Environmental impact was a key focus when selecting building materials. A mass timber structure saves both time and energy during the construction and fabrication processes. Mineral wool insulation has a high R value, but lower carbon impact than more traditional materials such as polystyrene or spray foam. Terracotta panels are used on the exterior, which are 100% recyclable and don't use harmful chemicals during fabrication. These all reduce our embodied carbon impact. For an initial building cost estimate, we split up the square footage into 3 different programs: office, retail, and daycare. Using the assumption of a high quality construction materials cost per square foot and a Chicago location adjustment in RS means, we reached an estimate of about $42 million. For the solar panels, we used average costs per square foot to get an estimate of about $840,000.
To improve the resilience and lifespan of the building, it has been designed in such a way that it can be converted into a residential tower if its original purpose as an office building is no longer in demand. The central vertical circulation becomes enclosed in a hallway, and the floors are divided into studio, 1, 2, and 3 bedroom units, providing a variety of housing options. With the dream of not only revitalizing our site, but also bringing downtown Chicago into a greener, more sustainable future, we are proud of our project as a new landmark on Chicago's skyline. Thank you for helping us aspire for that better future.
Thanks, Illinois Institute. You were great. I will now open it up for question and answers. Would either of the jurors like to go first and ask questions?
I'm happy to. Yeah, I have wonderful presentation. Loved it. Loved the building. Thank you so much. All the great analysis and especially getting all this into 8 minutes. Lots of good innovative ideas. I did have some questions about the costs. Did you do market analysis on cost thresholds, average dollars per square foot for a typical building in Chicago? And how are you looking in comparison to another building, another similar building? You have some kind of expensive facade elements there. And so I'm just kind of curious about your cost analysis.
Our cost analysis, we used kind of a basic parametric estimate that didn't really go quite into as much detail with all of our building materials. That was going to be part of our next steps. But we did do a bit of a market analysis with similar buildings around. And yeah, our goal is to, reduce costs.
We have done some comparison to our building estimate with other buildings of a similar sustainability goal and location and square footage in the area, and they are of a similar price per square foot. So we did find that.
Great. And then I have one more question, then Lisa, I'll let you go. So you have open floor and shading. Love the daylighting analysis. Thank you. That was great. Also, I think some of the acoustics of that, having, lots of people sit in open floor plans right now that have some kind of problems with noise and interactions. Did you think about anything along those lines in terms of like the programming and how you might deal with that?
We have not gotten into a detailed acoustic analysis yet. If I can go back to the floor plans, we do have some devices on the ceiling to try to reduce noise traveling across the entire space. It is something we are planning on looking more into detail about.
That'd be great. Any innovations in that would, I think, be welcome in the market. Thanks. I'll let Lisa go now.
Yeah, same comments. Great presentation. You guys really covered a lot. I love the meaning behind the name and the location and the context of the place. So, and also the durability, thinking about office buildings in the future and thinking about it being converted to housing. It's a beautiful thing. I love it. Also, like the daylighting analysis, just a question, what modeling software are you using to do that? And are you using, I think I saw illumination down at the bottom, but I was wondering if you're doing it more like the SDA analysis as opposed to just a certain time during the day. Oh, you do have that there. Okay, cool. I think I missed that at the top.
Yeah, we use Sapphira and its integration with SketchUp to do this daylighting analysis.
Perfect. I didn't really have any other specific questions other than asking about that, but again, I think it was a really great presentation. I think you covered a lot. I agree with Amy's comments that the facade does look a little sort of expensive. I don't know if you need insulation under the PV panel, right? You need to make sure, like in passive design strategies, you draw your red pen all around the building, but you may not reduce some cost by getting rid of the insulation outside of the building envelope. Thank you, guys.
Awesome, thank you.
Do I have a minute for one more question? Because I have one more.
Yeah, go
Okay,
ahead.
awesome. Thank you. So I actually was also wondering about the comparison between Sapphira and Open Studio. That's pretty different. Any thoughts about why?
Yeah, Open Studio actually has a lot more chance for different inputs about, all of the materials and space types and thermal zones, whereas Sapphira, it kind of just uses, there's not as much of a chance to like break down spaces and, assign the different like systems and thermal zones and everything. So Open Studio just gets a lot more detailed, which, so it can pick up on a lot more things that would require energy.
And did you use Sapphira specifically for the SketchUp daylighting capabilities, or were you looking to compare the two, or what was the purpose of that?
Sapphira, we were working a lot with one of our professors who was showing us Sapphira, and it was mainly used to kind of optimize the massing and figure out what HVAC systems we could or use the least amount of energy, because you can change the different HVAC systems in there, and you can quickly change like different parts of the massing, whereas it takes a lot longer to do that in Open Studio. Yeah. So we did a lot of those big decisions based on Sapphira and then kind of narrowing things down in Open Studio.
And you're planning to move forward with Open Studio, it sounds like, and
yeah,
okay.
It's a little more realistic.
Maybe, I mean, it's really different. So that's a big question. Anyway, okay, thank you.
Thanks.
Awesome.
Thanks, Illinois Institute of Technology. That was wonderful. Next up, I'd like to invite Fitchburg State University to do a quick AV check. If the speaker would just like to turn on their video and we can make sure your audio works, and if you can share your screen and the slides look good.
Hello, good afternoon, everyone. I'm the faculty lead for Fitchburg, and our school is special in the sense that everybody's working. So most of my students, I teach them in the morning, and the slot was 12 to 4. So I could have got somebody before 12:30, but he has chemistry practicals. Other people are at work. So I don't know what happens if they are not here, because you said the faculty should not present, right?
Right, yeah, we do need the students to present. So they're not able to join us.
Yeah, they can join by this time.
Got it. All right. Okay, in that case, yeah, let me reach out to you and figure
Okay,
out
please
if we
reach out
can.
if you can get another time for tomorrow or something else, but they're not here, so.
Got it. All right. Yeah, thanks for letting us know. In that case, our next presentation is by Concordia University. That'll begin at 1:10 p.m. So we can take another break and rejoin at that time. Thanks, everyone. All right, we're at time. Can I invite Concordia University to do a quick EV check before they start their presentation? If the presenters want to turn on their video and also share their slides.
Hi, how's it going?
Hey,
Hello.
Hi.
Hello.
Can everyone see my screen?
yes, we can. Looks good. Are there any other presenters that just want to check their audio, or is it just going to be you?
Yeah, we're all here.
Okay.
Yeah.
Cool. And yeah, I think I can hear all of you, so you're fine. So we will begin the presentation at 1:12 p.m. Eastern time. So I'll just let you know when it's time to start.
Beautiful, thank you. So we can start? Well, it's
Yep.
1:12 on my beautiful.
Yes, we're at time. Go ahead and
So
start.
beautiful. So hi everyone, we're MNDG Corporation and we have an office building. So here's our office building in the background. So our building, so here's our team. We have our structural team on the left, our envelope team in the middle, and we have our HVAC team on the right. So our building is located in Montreal on the intersections of St. John Street and Peel Street. And it's in the area called Griffintown, and it's close to the ETS Pavillon B. So here are three other views of our building. We can see here the bump out on the front. Here a side view of the large curtain walls.
As for the structural design of the building, we decided to make the building out of steel. We did this due to the fact that it is more environmentally friendly, considering that 90% of steel used in the industry today is recycled, as well as the fact that it will provide really nice aesthetics in the building because we're hoping to leave a lot of it exposed, which isn't very common in Montreal. In addition, we are aware that it will need fireproofing, but that will be taken care of.
So here are the structural plans of our building. So we can see that our building is fairly irregular, which gave a lot of iterations for our calculations. We could also see our shafts for our elevators and our stairs, and additionally another shaft for a staircase that also leads to the roof.
Once again, just in terms of structural design, we started by designing our columns. To do so, we needed our dead, live, and snow loads on our roofs in order to be able to estimate the size of our columns using the Handbook of Steel Construction. We also made sure to follow along with the NBCC, and basically once we selected all the columns, we standardized them for simplicity of construction. And then the same was done for the base plates of each column.
Yeah, same thing was done with the girders. We designed 44 different girders and they were standardized to these 6. Same thing for the secondary beams and they were standardized to these 7 different sizes. We also designed our slabs for our building. The slab of the main roof was slightly thicker due to the equipment load for the HVAC.
And then in terms of structural design, we also built the model in ETABS. Then once we did this, we were able to run simulations, which you'll basically see on the next slide. We have our shear and bending moment diagrams, and then those were our results of that simulation, which came to be rather close to the hand calculations that we had done to estimate the columns and all the other structural elements. However, there was some discrepancies, and that's due to the fact that in the software we standardized them, whereas when we were doing them by hand, they weren't.
And for structural, all we have left is redesigning the decks because they do take lateral loads in steel buildings, and as well as the CBFs, which have to be done.
So for the building envelope, the main objective of the building envelope design is to promote energy efficiency by reducing the energy load on the building. Next slide. To do so, the brick wall composition has 2 different layers of insulation. One, to increase the RSI value to 5.48, higher than the NEBC requiring 4.17. And 2, to reduce any thermal bridging that could occur through the metal studs of the wall. As for the roof, the same concept applies for the RSI values, determining a tentative value of 9.074 on the therm softwares, while the NEBC required approximately 7. Additionally, for the white membrane of the roof, it will reduce heat absorption by having a reflectivity of around 75%.
So as my colleague mentioned, there's 3 compositions that were utilized in the condensation check. The condensation check was basically attained by using glacier method. And later on, we'll have to compare this because glacier only is it doesn't consider all factors. So WUFI will have to be used later on to consider all these factors and give us a more in-depth analysis. Here we can see the brick wall composition, and it's the only composition you'll see that has condensation occur. The condensation occurs between the interior facade of the brick and that of the exterior facade of the exterior insulation. A simple solution to solve this issue is by basically putting a sealant on the brick. And also in the table above, you could see that a correction factor was done so that basically no condensation occurs. If you proceed to the next one, you'll see an inverted roof. There was no condensation that occurs. And as well as in the green roof, which is the next slide, no condensation occurs as well. The thing that's important to understand, when we did glacier method, the ceiling, the plenum airspace, as well as the ceiling, drop ceiling panel, were not considered in the composition because these are not fixed elements within the composition. They can always be removed, and the ductwork, along with other elements, could be left exposed. Thanks.
As for the curtain wall, a triple glazed with argon filled composition from a company called Vircon was selected, as well as an aluminum frame from a company called Conair. The combination of both these factors result in a U factor of 1.639 with a solar heat gain coefficient of 0.361. These values are tentative as certain changes within the frame might be edited to get a better U factor.
In addition, we wanted to incorporate several innovative technologies, but as time progressed, there were some of them that we don't deem acceptable anymore. One of them being is the double skin curtain wall that was going to be located on the 3rd to 5th floor, facing the southeast and southwest facade. This is because when we were trying to run simulations, the double skin curtain wall is just we're not capable to run an accurate reading due to the programming not being able to provide it. Another technology that we wanted to incorporate is a green roof on the 2nd floor on the northwest facade. This is basically a balcony that's going to help us be more energy efficient, as well as an inverted white roof on the main roof of the building, as well as solar panels that are going to be utilized to, well, not utilized, but incorporated in our ductwork system.
For our integrative design, we are starting off with PVT panels, solar duct PVT panels. The purpose of this is to heat the outdoor air going into the DOAS system. By doing that, it decreases the heating load of the entire building. We are also, as I mentioned, putting in a DOAS system, which stands for Dedicated Outdoor Air System, which its whole purpose is to supply 100% outdoor air as per ASHRAE standards. Downstream from the DOAS system is fan coil units with cassettes. So the fan coil units will be used in larger areas, such as the retail spaces, while the cassettes will be used in smaller office spaces. As you can see, we mentioned a 4-pipe system instead of 2-pipe. We're going to use 4-pipe because it can do both heating and cooling at the same time, compared to 2-pipe, which is only just heating or cooling. That maximizes the comfort for the occupants. For our cooling system, we're going to have a water-based chiller in the basement, which is going to be connected to a cooling tower on the rooftop. That's going to supply the cooling coil in the DOAS system, as well as the cooling for the fan coil units and the cassettes. For the heating system, we're going to have a hydronic heating system with a boiler. That's going to supply the heating coil in the DOAS system and perimeter baseboard heating, as well as the heating in the fan coil units and the cassettes. Here you can see our hourly analysis program from HAP. Our cooling load came out to 10.2 tons. Our heating load is 184.7 MBH, which is 15.4 tons. And our minimum CFM needed, our actual max CFM outdoor air needed is 8,020 CFM.
Sorry about that. So the energy analysis we're building was done through eQuest, where the total energy consumption was calculated to be 252 megawatt hours, and for heating, 765 megawatt hours. The monthly energy consumption.
Sorry to interrupt you. You have, can you wrap up here in a couple seconds? Your time is up.
Yeah, sorry. Okay, so our monthly energy consumption, you could see it on the graph below. Our site AUI was calculated to be 234 kilowatt hours, whereas the average in Canada was 289. So this is a decrease of 90%. However, an AUI of 234 is very high, so this will have to be fixed for the final report. In terms of the cost for a building, the total annual bill is going to come out to around $64,000 per year. And for the cost estimation, structure is allocated to $3 million. Envelope is around $4.9 million, and HVAC is around $3.4 million. Thank you very much.
Thanks, Concordia. I'd like to open it up for question and answers. Lisa, would you like to go first?
Sure. Thank you guys for your presentation. A lot of information. I am an architect. I wondered if we could just go back to the floor plans, just so we can understand the building a little bit better. I also, while you're finding that, were you guys planning on doing any embodied carbon calculations or modeling? I know you mentioned you were using steel and concrete.
We want to. Yeah, we were planning on doing embodied carbon to compare steel, concrete, and wood for our final submission. Yep.
And then in terms of trying to reach sort of the zero energy carbon goal, sort of maybe perhaps looking at that over the lifetime of the building as well might be an idea.
Yeah, it's in the works. Yeah.
So is this another just piece of advice again from the architecture side is having a typical floor plan more with how are people actually using the spaces? How are they experiencing the spaces? Is it open office? Is it closed offices? Where are they gathering space?
Yeah, like these are just our structural plans. Like we didn't include our floor plans. That our mistake. Maybe we should have. But yeah, like it.
Sorry, the floor plans are in our report submission though, in the appendix of our report.
Yeah, we just didn't put them in the report because there's still stuff that we had to modify and alter because the project's not finalized. So like as of late, we had to extend part of the walls for structural loads and all that. So that's why we didn't incorporate it, because there was always going to be modifications occurring. So rather than incorporate it early on and show it, we wanted to just give it the final report. And we're also limited to what we could present.
Thank you.
So really, really great deep engineering analysis here. Thanks for that. And I agree with Lisa that, you know, some of the architecture would have been nice to see as well. I am curious what was going on with the curtain wall modeling. You couldn't model the curtain walls, or you had to.
We wanted to incorporate a double skin curtain wall. Dave, can you show at the beginning? I think it's the second slide. If I'm mistaken. Go down.
Wait,
you see,
this.
Yeah, on the right hand side.
On the right.
We wanted to put a double skin curtain wall there. And basically you see like the second curtain wall would be basically divided to interior spaces, some offices and all that. The problem is when we want to use eQuest to model this, it doesn't read it, like it doesn't work out to be, we're not capable of modeling this double skin curtain wall.
We are, it's just that the values we get show overheating during the summertime. So this is, the eQuest analysis is able to be completed on the double skin curtain wall, but it doesn't prove to be beneficial for our location because during the summertime it creates more of an energy load. It creates more of an energy load issue. So that's the issue with modeling it currently. So our solution would be to either implement some sort of shading device for the summertime, or cover the interior curtain wall used as a hallway. We would cover the secondary curtain walls, just partition walls for the offices, with some certain window like spacing for windows.
So eQuest is a pretty rudimentary energy modeling tool. I'd encourage you to explore others if you have the opportunity. And I think that the double skin curtain wall is always a problem for energy modeling, but I'm glad that you got to that result and can accommodate sort of your local climate. I'd also suggest discussing that a bit more and in terms of how you've developed your HVAC strategy. Because local climate can really enable energy reduction. So your energy is high per square foot, but if you start to think a little bit about how you can use your local climate and maybe some moderate days to offset some of that load and then reduce your internal loads, you'll be able to, get that energy number down quite a bit more. I like the solar preheat on the ducts. That's something I've not seen before, but I might be out of it. That's an interesting idea. So thanks for the great engineering analysis. I agree. There needs to be a little bit more architecture in here. And I encourage you to push the envelope on your HVAC too. You have a fairly normal, standard HVAC system design, but maybe think a little bit out of the box and explore some other more innovative approaches to heating and cooling.
Yep, we could definitely do that.
Thanks again,
Thanks.
Concordia.
Thank you.
Thank you so much.
Thank you.
Thank you.
Have a great day.
Have a good day.
So we have a short break now, and we'll be back at 2:05 p.m. Eastern Time and start with Wentworth Institute of Technology and their presentation. So we'll see you all shortly. All right, looks like we're at time. I see that Wentworth University is here already. So if we can do a quick AV check, if you guys want to just share your screen, share your slides, and we can also make sure your audio is working.
Yep, perfect. Can you hear me? Perfect.
Yeah.
We're all in one room, so we'll have one audio on, but we have all our videos on, just so we don't overlap.
Sounds good.
Let me share my screen.
Do you also want to check that Amy and Lisa are back?
Yes.
I'm here.
I'm here.
Perfect. Are we all good?
So we still have a few more minutes to go.
Okay.
You guys can start presenting at 2:07. I'll let you know when it's time to start.
Perfect.
If you're at time, you can go ahead and get started.
Awesome. Perfect. Hello, everyone. Thank you for coming and welcome to the Habitat. The Habitat is a cutting-edge example of a mixed-use commercial office building that focuses on creating a complete environment and utilizes the need to adaptively reuse previously developed sites. The project stretches beyond the site's borders to combat issues such as climate change and the decline of local ecosystems. For the past 6 weeks, our team has tried to create a design that considers all of the community stakeholders, not just the users of the building. Our team, faculty advisors, and industry partner, New England Development, envision a place that is resilient for the present as well as the future, energy efficient, and a place people desire to be. Overall, we transform a site that is home to an obsolete grocery store into a fully integrated and educational one that provides a glimpse into the future of building standards. Our team is comprised of 6 members: Hilcius De La Cruz, Nathan Kalaniak, Jessica Cavett, Matthew Kukowski, Ray Liu, and myself, Evan Clark. We are also accompanied by 2 faculty leads, Troy Peters and NJ Naka, as well as 2 industry partners, Jim Fisher and Caroline McGina from NED.
Our project site is located in Watertown, Massachusetts, with a population of 35,000, with 65.7% of residents holding bachelor's degrees. The median household income is just over $100,000, and there are 7 bus routes that run through the city of Watertown. And it's a 5-minute bike ride from our site to Cambridge. Another important part of our site is that the Charles River Greenway starts in Boston at the Museum of Science and goes past Watertown and is a part of the southern part of our site. It's a 7-minute drive from Interstate 90, a 15-minute drive from Harvard Square in Cambridge, and a 20-minute drive from downtown Boston. We're also using this building as an opportunity to create more jobs for an array of Watertown residents, with teen and young adults working in retail space, established adults working in office space, and ecologists and environmentalists working in the greenhouse, the rain garden, and beekeeping around the site.
As mentioned in the intro, the site is previously developed and is home to an obsolete Stop and Shop. It is predominantly paved and pays little to no attention to the existing floodplain and river setback, stormwater quality or storage, energy resilience, retail visibility, or even human connectivity. There is also minimal connectivity between the Charles River Greenway and the rest of the site. The existing building allows us for the opportunity to reuse some of its materials. This strategy is accomplished by individually sorting the materials on-site or reusing them off-site for another project. Reusing existing materials is an environmentally conscious decision that preserves embodied carbon. Even though this will increase the project's total construction cost, it'll be minuscule in the long run. Looking at a proposed site plan, we utilize the elevation change to create a retail level that activates the site and attracts people from the main road through our building and towards the Greenway. An additional traffic lane is incorporated to encourage rideshare as well as local bus transportation. The landscape beyond the building was also manipulated to redraw the flood line so that potential storm and floodwater surges don't interrupt the operations of the new building. Visualizing the proposal in the third dimension, a simple massing illustrates that we have shrunk the existing parking footprint so that the retail will be at grade with Pleasant Street, which in turn creates 125,000 square feet of pervious surface. The site allows for the building to be properly oriented so that solar gain on the southern facade is maximized. This long facade gives us the ample opportunity to implement renewable photovoltaics that will save a significant amount of the building's operational energy use. We also integrated a full building height greenhouse that creates an interior habitat.
Gaining the elevations and overall facade design of our building. On the bottom left of your screen, you're going to see our south facade. That's going to house our greenhouse. As you can see, there's a lot of glass, which is going to bring in a lot of natural light. That also houses the solar PVs that Evan was talking about. Above that is going to be where our north facade is. As you can see, we have two separate masses that are connected by a central atrium space that obviously, as you can see, brings in a lot of natural light as well. On the right side of your screen, you're going to see our east and west elevations. As you can see on the first two levels, you're going to be made out of concrete. Obviously, that's going to bring out a lot of carbon. To counteract that, we're going to line those with a lot of vegetation to help with the carbon sequestration. Moving into the structure of the building, the diagram presented showcases a bay highlighting the structural assembly of the building. The structure is composed of on-site cast post-tensioning concrete that is located at the bottom floors, while the upper floors is composed of CLT walls and floors, as well as glue lamp beams, girders, and columns. The use of mass timber allows for the building to sequester carbon, allowing the overall R value of the building to double compared to a conventional building made out of steel and concrete. Using mass timber also allows for prefabrication steps to occur throughout the building, reducing on-site construction time. Continuing with the structure of the building, the diagram presented showcases a bay facing the south facade. The diagram showcases the structural components of the greenhouse, as well as the overall assembly of the building. The diagram also highlights the overall embodied carbon of the building compared to a standard steel and concrete constructed structure. Moving into the integrated component part of the building uses PV embedded glass cells located at the facade of the greenhouse. The energy collected from those PVs is then later distributed to the building systems, such as the geothermal ground source heat pump, as well as the radiant floor heating system.
To ensure the resiliency of our building, we implemented a rain garden between the building and the river. This will contribute to floodwater mitigation plus floodwater collection. Furthermore, rain garden collection systems will be added to the green roof to recycle rainwater through the building, as well as a gray water recycling system.
Moving on to our environmental impact, we've implemented podium parking to reduce parking square footage and promote heat island mitigation, promoting rideshare to reduce emissions traveling by bike, bus, Uber, and Lyft. And we've also implemented bike storage in the parking garage. We're using locally sourced materials and pollinators on the roof, helping native vegetation in the greenhouse, on the green roof, and around the site. Our annual carbon emissions is about 87 tons of CO2 per year, which is roughly equivalent to 18 cars.
Getting the overall occupant experience of our building, on the top left of your screen is going to be the interior of our greenhouse. That's going to house our farmers market. Below that's going to be the interior of the atrium space, bringing in all that natural light I was talking about on the north facade. On the top right of your screen is going to be another rendering of south facade where the greenhouse is going to be. You'll get some of the bioswale there in the foreground.
And below that's going to be what the building will look like during a night experience. We have the AI automation monitors to control our radiant floor heating system and also the mixed floor ventilations. And we have the operational energy schedule based on the occupancy systems. You can see on the right side graph is showing indoor air temperature change in a day. And the AI system temperature will rise to around 70 to 75 Fahrenheit during the office hours and will automatically decrease the temperature after the office hours.
Getting into comfort and environmental quality, the interior of the building features an enhanced air quality thanks to the greenhouse as well as interior atrium. These spaces create a chimney effect that are accompanied by mixed mode ventilation strategies to allow for maximum occupant comfort. The air within the greenhouse takes a step beyond due to it being purified from interior and exterior vegetation. The design green walls also act as a sponge that will sequester CO2 from the parked cars in the parking garage. Sufficient natural lighting is another key feature of the building, as seen with the direct light coming into the greenhouse and the farmer's market, as well as ambient light coming in from the skylight in the north facade of the atrium space. To mitigate overheating in the office and retail levels in the south facade, occupiable balconies were designed to provide passive shading that will lower temperatures while at the same time increasing occupant comfort and experience with views of the site beyond.
Moving forward with this design, we plan to do more research into interior layouts, MEP systems in detail, the facade, and construction costs. Thank you.
Thanks, Brentford. That was a very great presentation. I'd like to open it up for question and answers. Amy, would you like to go first?
Sure. Yeah, great presentation. I love the graphic. The presentation that you all put together was very beautiful. Thank you. I do think that a little bit more dive into the ventilation will be important here because of the solar gains that you're going to see through that greenhouse. It's a cool idea. I love the cleaning, the air cleaning, but I do worry a little bit about the heat. I also thought that the use of your materials was really exciting and important, timber and geothermal. Did you do an energy model, or are you planning on it?
Answer, Matt?
Yes, we plan on doing an energy model. We were able to calculate the embodied carbon of the building, which brought us to over its entire lifetime, brought us to around negative 700,000 kilograms per square foot over its entire lifetime, which is I consider pretty sustainable.
Okay, I just think when you dive into the MEP analysis that you're going to want to do some load evaluation, make sure you're, maximizing all of the, natural ventilation, all of the solar gains, all of that thermal opportunity that you have, and also orientation for that as well. The orientation of the building. I know you've designed it around the river, but there's also the sun angles. So yeah, thanks so much. Very beautiful presentation. Thank you.
Thank you. Thank you. Thank you.
I agree with Amy. Great presentation. I love the use of reusing old sites that are just kind of sitting there. So thank you for that. The site context. I didn't catch where the north arrow was. So Amy's point about orientation with all of the glass of the greenhouse and the farmer's market. So I really like the different uses, but I think using an energy model to help you kind of make some of those design decisions would be pretty useful. I love that you guys did embodied carbon calculations. That's great, because we really need to balance, right, the energy use of the building with that embodied carbon and think about it in its totality. And I like that you guys had a slide for next steps and things that you guys still need to do and work on. So thank you for including that. And
no problem. Yeah, thank you.
Thanks, University of Wentworth. We will now have University of Cincinnati presenting at 2:20 p.m. So we have a few minutes to go, and then I'd like to invite them for an AV check. Thanks again. All right, we're at time. Can I have University of Cincinnati turn on their video? And if you'd like to do a quick audio check as well as share your slides.
Hi.
Hey.
Audio working?
Yes, sounds good.
Hello.
Hello.
Hey there.
Hello.
Sounds good.
All right, can you see my screen?
Yes, we see it. It's not in full screen mode yet, but we do see your slides. Yeah, looks good.
All right.
Awesome. So we have another 2 minutes and we'll be starting at 2:22 p.m. I'll let you know when it's time to start.
Great, thank you.
All right, we're at time. You can start your presentation now.
All right. So hello, we are a team from the University of Cincinnati and we're in the office division. Our building is an architecture, engineering, and construction firm located in the city of Gouda in the Netherlands. Let us show you how to build. This is our team. I'm Grace White.
I'm Robert Cottingham.
I'm Ryan O'Callahan.
I'm Brett Liming.
I'm Will Harshberger.
I'm Josh Maley.
I'm Joe Mack.
And our faculty lead is Anton Harfman.
So as Grace had said, our site is located in Gouda, Netherlands, which has a temperate oceanic climate, where the temperatures average in the mid-70s during the summer to the mid-40s during the winter. This being in the climate also gives way to large amounts of rainfall monthly. Our site lays within this larger parking lot that you see, with being surrounded by other schools or other buildings trying to be net zero. This includes a school to the north, an RV sales, and senior housing to the south.
So we didn't want to design a building that was just net zero. We wanted to design a building that would inspire an actual change in its community. We did this by designing for 2 main goals. We wanted to demonstrate how great efficiencies can be achieved, and we wanted to educate the community on sustainability. We demonstrate by harnessing passive strategies, incorporating and displaying new and innovative technologies, preparing for the future by reducing the strain on the grid and using sustainable systems, and conserving resources and limiting environmental impacts. And we educate the community by encouraging learning through welcoming and interactive spaces, exposing the building's inner workings to its occupants, promoting awareness about smart living applications, and teaching AEC principles with hands-on learning experiences.
So there are 3 main things that we focused on when positioning our building on the site, which was the sun angle, the prevailing wind direction, and the site circulation. With the sun being at its peak to the south of our building and our close proximity to the school to the north, we decided it was best to position the building furthest northeast on the site, not only to capture enough sun for our building, but also to allow the school to capture sufficient levels of sun as well.
The first floor of our office features a do-it-yourself lab where members of the community can come to learn how to install solar panels on their homes or be inspired to install other energy-saving tools. This DIY lab is the central hub of our building as it embodies all of our design goals. The lab extends upwards through the entirety of the building to connect the work being done on each floor. Our office also features a learning lounge with a cafe-esque environment with books and other reference materials pertaining to AEC practices and technologies, as well as a classroom for in-depth lectures on building systems or products. Our intention for the second and third floors is to design a productive, collaborative work environment. The second floor features open collaboration spaces, conference rooms, ample desk space, as well as a large dining area that can be used for company meetings or lunch and learns. Each of the bathrooms on the second and third floor are equipped with private showers, as we are anticipating the majority of employees biking to work due to Gouda's prominent biking culture and wanted to offer them a place to freshen up before work. As you move up into the third floor, it becomes more private with individual office space, as well as individual workrooms. We all wanted to maintain a collaborative work environment, so we have collaboration spaces here as well.
Our glazed south facade is known as a buffer facade. The buffer facade is made up of 2 layers of glass with a 2-foot airspace between them. The air within the buffer facade will never come in contact with the air within the building and acts as an additional insulation layer to the building. The buffer facade has insulated louvers at the ends and rotating light shelves between floors. During the winter, the louvers and light shelves can be shut to allow light to bounce off these light shelves and penetrate deep within the building, as well as trapping heat within the buffer facade, giving us a smaller delta T
on our large facade. Due to Howda's moderate climate, we can use natural ventilation to supplement the cooling by having an intake of air through the windows on the north facade being pulled through the building into the DIY lab, which acts as a solar chimney which exhausts the warm air out through the roof. Within the buffer facade, we will let the air move through the facade and have light shelves shade and reflect light away from the building.
Our team has also utilized a green roof, not only for the aesthetics, but for added insulation on our roof and also ample outdoor space for the occupants within the building. We've also utilized rainwater collection in that space to supplement the watering of the plants on the green roof if needed. Our building is entirely powered by the sun, utilizing two forms of solar collection, that being solar thermal and photovoltaic panels. The graph shown shows that solar thermal panels can be upwards of 70% more efficient in producing heat than photovoltaics. So our team has designed our heating system to first use the heat produced from the solar thermal panels and be supplemented by the electricity produced by photovoltaic panels when needed.
Both types of panels generate the least energy during the winter and the most during the summer. Our building loads follow the opposite pattern, requiring the most energy during the winter when energy production is at its lowest. If the number of solar thermal panels were sized to completely cover the winter load, there would be a massive surplus of heat energy generated in the summer that couldn't be sold back to the grid because it's in the form of heat. Instead, we sized the number of solar thermal panels to cover the summer load, and we sized the number of photovoltaic panels to cover the majority of the winter load, so that any excess generation can be returned to the grid in the form of electricity.
To capitalize on the high generation of the solar thermal panels in the summer, we paired it with an absorption chiller. The absorption chiller takes the heat generated by the solar thermal panels and uses it as a power source to make cold water, which then runs to fan coil units in our building. We sized the number of solar thermal panels to completely cover our cooling loads. For our heating system, we chose to use radiant flooring because it doesn't require near as high temperatures as traditional systems to effectively heat spaces. Heat is introduced closer to occupants and utilizes the natural rising of hot air to evenly distribute the temperature. This allows our occupants to feel more comfortable with less energy spent. To supply our radiant floors, we will first use whatever our solar thermal panels generate, but it will mainly be supplied by our ground source heat pump, which is powered by our PV panels. Our heat pump has a COP of 4, which means that for every 1 kilowatt generated by our PV panels, 4 kilowatts of heat energy gets moved from the ground to our building. The high efficiency of both the heat pump and the radiant flooring significantly decreases energy consumption in the winter. We wanted to use both solar thermal and PV to showcase to the community how solar can be an effective renewable power source even in overcast regions such as the Netherlands. We hope to promote awareness of the proper applications of solar in the future infrastructure of Howda.
Energy use is an important aspect in sustainability in construction, but it's not the only factor in being a sustainable building. We went beyond net zero by also focusing on our construction techniques, material choices, and social aspects of sustainability as well. We performed carbon accounting using the one-click life cycle analysis tool to understand our environmental impact more holistically. This tool calculates the amount of greenhouse gases emitted in construction based on the building's material use and location, and helped us select more environmentally friendly materials. Secondly, we intentionally exposed our advanced net zero strategies, like revealing our mechanical systems rather than hiding them. We integrated our building with the greater community through our net zero energy corridor, for example, hosting students from the school next door to learn about energy reducing techniques and learn from design and construction professionals upstairs. Finally, we included do-it-yourself lab to teach practical skills like solar installation.
Hey, just as a reminder, you're at time. If you can just wrap up in a sentence or two, that'll be great.
We believe these design strategies will have a sustainable impact on and off this site.
Thank you for listening to our presentation.
Wonderful. Thanks so much. Let's move on to the question and answers. Amy, would you like to go first?
Sure. Beautiful renderings. Thank you for all of that. If you don't mind going back to slide 10, that was really cool facade element that seems like a lot of thought went into. Oh, slide 10, but also the solar thermal versus PV analysis. I liked that too. Well done. So you said that you have rotating light shelves inside of the building. Is that correct?
Within the buffer facade, we do, yes.
And then, so those are going to be like on an actuator or something. Have you seen those other places, or did you spec that out, or is that sort of a custom design?
It's kind of a custom design, but I've seen implementations done in different ways. Essentially, it would just be like a louver system spaced periodically through the facade. And then instead of having insulated louvers, it would just be reflective light shelves on it.
And did you do a daylighting analysis on those? Is that what the left graphics are showing?
Yes.
Cool. Awesome. Thank you. And then the only thing I missed was the cost. Did you all do a cost analysis and look at thresholds for the Netherlands?
We did actually do a cost analysis, but this was the wrong version of our presentation. But here, this is great. We have it in this one anyway.
Awesome. And what is the, did you look at the per square foot estimates? Did you have a dollar per square foot estimate for it at all? Is it?
Yes, we doing our estimation, we got around $750 to $800 a square foot, so fairly expensive.
Even for Netherlands standards?
Yes, yes.
Okay.
But I think that also comes into play with the amount of systems that we have coming towards the net zero side of things.
I agree. And I think you could propose some cost benefit analysis, sort of the return on investment of some of those systems as a part of your next strategy. But yeah, great job. Thank you.
Thank you.
Yeah, I agree. Great job, everyone. I also really like how you guys presented as a team. So lots of times architecture firms, when we go in to win jobs, we do exactly what we did, right? I talk about architecture, Amy talks about systems, and you have the person talking about the thing that they're the expert at. So I really like that. I like the fact that your project is an architecture, engineering, construction office. You talked about your goals of demonstration and education, reaching out to the community. You did the site analysis, all that I thought was really great. And agree with Amy, I think with such a high construction cost, really showing that cost benefit analysis over the time and incorporating that again with the embodied carbon benefits too. So good job.
Thanks once again. That was a great presentation. We now have Monash University presenting at 2:35 p.m. So we still have a few more minutes to go. And at that point, I'll welcome them for the EV check.
Great. Well, thank you so much for having us.
Thank you. Thank you.
Thank you.
Thank you.
Are we good to log off, or should we stay on for a couple more minutes?
It's up to you. Yeah, but you're all done with your presentation, so you can log off if you need to.
All right. Thank you.
Yeah. So we're at time. Can we have Monash University turn on their videos, and if you want to do a quick sound check as well as share your slides so that everything looks good.
Hi, I'm Elita. Can Ego do a sound check?
Hello, I'm Ego.
Jacob.
Hi, I'm Jacob.
Awesome. And then can the room check as well?
Can you guys hear us?
Yes, we hear you. Yeah, sounds good.
Awesome. That all the sound checks are done.
Great. Awesome. Yeah, if you wanted to also share your slides, we can make sure we're able to see them, and then you will start your presentation at 2:37 p.m. So you have 1 more minute to go.
Perfect.
Yep, looks good. You can see your screen. Yeah, I'll give you a heads up when you can begin presenting.
Thank you.
You can start presenting now.
Hi everyone. Our office building division team is part of the Monash Sustainable Buildings from Monash University here in Melbourne, Australia. We had graduate students from multidisciplinary backgrounds, including engineering, commerce, and architecture. And we are excited today to share with you our design, York and Clarendon.
York and Clarendon was designed to accommodate the post-pandemic work normal. According to the Property Council of Australia, building spaces in Melbourne's Central Business District, CBD, were still half empty in November 2022, despite the lifting of work from home recommendations earlier in the year. This trend was a result of companies downsizing to accommodate remote staff and a shift away from the CBD to fringe suburbs. The latter being popularised by maintaining accessibility to transport and amenities, whilst benefiting from a slower pace and increased connectivity. Inspired by this, we have created a co-working space where companies and individuals can choose an open pass to access shared workspaces for a day or rent a floor long-term, with various options in between. Our selected site is on the corner of York and Clarendon in South Melbourne, an inner-city fringe suburb about 2 kilometres or 1.24 miles from the CBD. South Melbourne is 25th in Domain's livable suburb ranking, with top 10 scores for culture, public transport, and walkability. The site itself is conveniently located along a tram line and less than a 10-minute walk to 2 alternative public transport options. It is also within walking distance of all 4 major Australian banks, 3 chain supermarkets, and a renowned local market. Our key design goals are sustainability, innovation, community connection, and flexible work options. This aligns with the Victorian State Government's guide, Plan Melbourne 2050, for the growth and creation of a livable, connected, and sustainable city. Using these goals to guide our decisions, we're striving towards meeting Green Star, showing Australian materials and systems, creating a space where the community can come together, and providing flexible work options to individuals and companies. The local Climate Zone 6 and the Australian National Construction Code, specifically Commercial 1 zoning rules, were not limiting factors in our design.
Our design concept is centered around creating an office building that serves both its workers and the public, representing our goals of flexible work options and community connection, respectively. The floor plan can be considered in 2 parts. On the right are the publicly accessible spaces, which include a cafe, a function room, and a multi-purpose games room. This side of the building is open to the public and to the office workers. On the left are the dedicated and secured office spaces, with each floor is fitted with individual workbenches, separate meeting rooms, and sofas. For companies choosing to rent out an entire floor, they may want to change the furniture arrangement or add more storage options, and having modular furniture and a service lift enables them to do so. For individuals or small groups who come into the space, whether it be for a day or for a year, all furniture and spaces would be communal. Someone could choose to work at a bench in the morning, move to the cafe for a working lunch, and book a meeting room for a Zoom call in the afternoon. The workers will not be restricted in their work location, instead encouraged to pick a space that best suits their needs at that time. To achieve a circular end-of-life plan, we selected recyclable and biodegradable materials, such as cross-laminated timber, recycled plastic bricks, and recycled aluminium framing. A focus on selecting insulation produced with naturally grown or repurposed industry waste, such as plant-based, polyurethane, rigid foam, and wood fiber, further contributes to this circularity. CLT formed the main structure of the building, contributing an estimated 22% lower global warming potential in comparison to conventionally used reinforced concrete, and the added benefit of protection from termite attack.
To design a building that meets the target EUI aiming for net zero and a Green Star recognised rating, an array of energy efficient and passive design features were to be included. The staircase design of the building optimised natural light for the specific intentions of both office and commercial use. The window selection was also pivotal to lowering the EUI substantially, with inclusion of double glazing, argon gas filling, and E3 coating. This allowed visible light to still enter while retaining high insulation qualities. We also selected a commercially proven 225 kilowatt solar panel system and a water-based heating system. The competition required us to aim to meet a target EUI of 52 kilo BTU per foot. We have steadily been walking towards this goal, reducing the EUI drastically from 180 to 75 over the course of the project. However, we are still some ways off due to the large scale of our building and complexity of the shared office commercial design. Other factors which help lower the EUI as seen in the graph were sensor strip lighting, heat recovery vents, and equipment with high energy ratings.
48 HRV units will be used to provide up to 92% heat recovery. This will reduce the overall amount of energy needed to heat and cool the building. These units measure the CO2 concentration of the room air and automatically regulate the air output to keep CO2 level below a set value. The mechanical ventilation system also provides filtered air, which will benefit occupants' health and well-being. The air-to-water heat pump by Ream is capable of heating up the building as well as providing hot water supply. With a stackable design, multiple heat pumps work together to meet the heating and hot water needs of our building. With a coefficient of performance up to 4, it can provide us with energy efficient and effective heating solution.
Our design recycles grey water using an energy efficient Aquacell G20 filter. This will conserve approximately 5.7 million litres of water annually. The water collected will be used again for toilet flushing and with the Marley Series 15 cooling tower to cool down the building. The staircase design on the commercial side allows more natural light to enter the upper levels of the building. This, in conjunction with an optimal window-to-wall ratio, which further increases the amount of natural light, reduces energy expenditure on artificial lighting. These two diagrams compare the difference in incoming natural light intensity between the ground and top floor. The building will implement sensors in order to optimize lighting and HVAC needs. The LED light bar used for lighting is capable of mimicking natural daylight to improve occupant experience and worker productivity, and has an increased energy efficiency of 15 to 20% over conventional lighting systems. We also intend to use a swipe card access system, which will be useful for the building's co-working concept.
So between now and the final submission, team intends to delve deeper into a variety of different areas to achieve all the competition targets and to emphasize our own design goals. The 5 key tasks we undertake are completing detailed financial and structural analysis, calculating the payback period for our solar tariffs, incorporating a green roof and green walls, and continue to lower our building's EUI. And to conclude, thank you to our industry partners, Monash University, Design Builder, and Efficiency Matrix, and thank you to you all for listening to our presentation.
Thank you, Monash. That was a very impressive presentation. I'd like to open it up for question and answers. Lisa, would you like to start?
Yes, great presentation, everyone. Very professional. I love the connected sort of backgrounds, everyone talking to their parts. The slides are very clear with what context you're sort of speaking to, and again, how it connects. I love that you talked about the co-working, the overall ideas and the design goals. That was useful to just hear from the beginning. One piece of advice might be to come up with some sort of catchy title or theme or something that kind of brings all of your ideas together, because I think the name was just sustainable building, office building, or something like that. So that might be useful. You talk about a lot of great ideas, so maybe just have something like a tagline to bring it all together. I love the EUI breakdown process chart of how you're getting lower and lower and how you still need some work to do there, and the timeline of your next steps. So thank you. Amy?
Sorry, I think you're on mute.
There we go. I'm sorry, I was double muted. I love the approach to the mechanical systems. I thought it was very innovative and thought out. I also appreciated the sort of multifaceted approach and the integrated kind of approach to iterative, is the word I'm looking for, approach to energy reduction. I actually don't have any questions, but great job. Thank you.
Thanks, Monash. Yeah, you guys did a wonderful job. With this, we conclude the first day of semi-final presentations. I'd like to thank all our teams for presenting. You all were wonderful. And I also want to thank our jurors for all their comments and feedback. We will be doing the second day of semi-finals tomorrow, and we start at 8 a.m. Eastern time. So I look forward to seeing you all tomorrow as well. Thank you once again. Before we leave, we'd love to do a group picture if everyone's able to, whoever's able to switch on their videos, we'd love to just capture everyone and do a virtual group photo. I can see Monash, you guys are on. That's awesome.
Quick clarification, it
Oh,
is
yeah.
10 a.m. Eastern.
You're not.
Just a quick
clarification for everyone is that tomorrow we will start at 10 a.m. Eastern.
Yeah, sorry about that. We're in mountain time here and I've been confused all day. So, but yeah, thanks for that clarification. Okay, yeah, this looks great. Let me do a quick screenshot.
Also one other thing, are we having that group event tomorrow or today? Tomorrow.
Okay, looks wonderful. Thank you again for joining and we'll see you tomorrow.
Thank you so much.
Thank you.
Thank you all.